All right. Hello. My name is William Pitts, and this is my Chapter 1, Chapter 2 examination. I am going to be covering question 2 today on the homework, and yeah, I hope you enjoy. So I got it pulled up on this other screen right here so I can read the questions. And let's get right into it. So we're going to start with part A. And so part A says vector A has a magnitude of 5 and is at an angle of 36.9 degrees south of east. Vector B has a magnitude of 6.40 and is at an angle of 20 degrees west of north. And now it says find the components of vector A for the first part. So when they ask for components, they are asking for the x and y components. In this case, sometimes there's a z component. But so they are looking for us to find a of x and a of x and a of y. And so we do this by plugging in the magnitude and the angle that they gave us into the equations for component form of a vector. So, and that equation is going to be v of x, so this is for the x component, v of x equals v cosine of theta, and v of y equals v sine of theta. And the angle that they gave us, so vector A, let's just write this out. Vector A has a magnitude of 5 and an angle of 36.9 degrees south of east. So what I like to do is I like to draw it out so we can figure out where that angle is actually pointing. So 36.9 degrees south of east, which means we have north, east, south, and west. And so 36.9 south of east, which means we go east and then we go north. So, just kind of guesstimate 36.9 degrees south of east. Now, the way that I like to do it is to find the angle that it would be in the positive quadrant. So depending on where the vector is, the v of x and the v of y will either be positive or negative depending on where it's pointing. So like for example, if we graphed vector b, which is going to have a magnitude of 6.40 and an angle of 20 degrees, and it's west of north. So we go north, and then we go a little bit west, and then that would be 20 degrees off of the positive y-axis. So the x component of this is going to be negative, and the y component is going to be positive. The x component of this in the first quadrant is going to be positive, and the y component is going to be positive. Down here, the x will be positive and the y will be negative, and then over here everything is negative, the x and the y. Now, if you don't want to have to remember all of that when you're plugging it into these equations, you can find the positive angle for all of these angles. So for example, vector A, so that's A, and then this is B. Vector B is down here, and so to find the positive angle of this, or the actual angle is, what I would call it, if you're going from the x-axis all the way around, this angle would be 360 minus whatever they give us, so 36.9. So if we calculate that out, 360 minus 36.9, the actual angle is going to be 323.1. And then for the b vector, the angle is over here, so we would take 90 because anything off of this is 90 degrees, and then we would just add 20 degrees to 90. So the actual angle would be 110. So, but I'll show how to do it both ways for this part. So for part A, they're only asking for a of x and a of y, so we don't have to worry about b yet. So if we were to plug this into these equations, so v of x equals v cosine and v of y equals v sine of theta for each of them, it would be a of x equals a cosine theta, and a of y equals a sine theta. And that's the magnitude of a, which is the magnitude they gave us, which would be 5. So then we would plug these in. A of x equals 5 cosine of, we can do it, we'll start with the angle that they gave us, so cosine of 36.9 degrees, and then a of y equals 5 sine of 36.9 degrees. Now, in order to figure out which one is positive and which one is negative, we look at where the angle is. So it is a positive x, so we're going to have a positive 5, and then a negative y, so it's going to be negative 5 sine 36.9. And then if we plug all these in, I'll write it out again over here, a of x and a of y. So if we plug this into the calculator, 5 cosine of 36.9, that is going to be 3.99, which we can round to 4. So that's going to be the x component. And then for the y, we have negative 5 sine of 36.9. And that's going to be 3.00, negative 3.00. So that can be negative 3.00. And that's going to be the x and y components for part A. So that's the whole thing. But now I'll show how to do it using the true angle, I guess. And that would just be plugging this in instead of the angle, and then not having to worry about the positive or negative. So a of x would equal 5 cosine of 323.1, and a of y equals 5 sine of 323.1. And so if we do that, 5 cosine 323.1, that still gives us 3.99, which would be rounded to 4. And then if we do 5 sine of 323.1 degrees, that'll still give us negative 3. There we go. It'll still give us negative 3.002. So both ways to do it. And yeah, so that's how to find the different component forms of a vector. And so now we'll go to part B. So part B says find the components of vector B. Okay, so we got vector B, it's over here. We know the true angle is 110 degrees, and so we can just plug it into this same formula, v of x equals v cosine theta, and v of y equals v sine theta. And then we just sub in b. So b of x equals b cosine theta, and b of y equals b sine theta. And then we plug that in for the values that were given. So we'll just write it again down here, b of x equals magnitude of 6.40 cosine 110, and b of y equals 6.40 sine of 110. And then if we just plug that into the calculator, 6.40 cosine 110, we are given negative 2.188, which we can round that to negative 2.19, because it's 188. So, and then if we just type in the other one, 6.40 sine of 110, we're given 6.014, so we can just round that to 6.01. And that's going to be for the bx and by here. I'll write it out again. Bx equals negative 2.19 and by equals 6.01. And that's for part B. All right. And now if we move on to part C, it wants us to calculate, it says calculate the scalar product of vector A times vector B. So it wants us to find vector A times vector B. And for that, we can use the scalar dot product formula, which is vector A times vector B equals A of x. So the component A of x times B component x plus A component y times B component y. And then the formula also includes plus A component z times B component z, but we are not given an A or a z, so we can just kind of ignore that part because that would just be plus 0. And then we have all the components written out here. So we have the b of x, b of y, and we have the a of x and a of y. And so we can just plug them into this formula. So we'll have a component, or vector a times vector b equals, actually, let me write it further down here so there's more room. So a times b equals, okay, so for a of x, we got 4. So 4 times b of x, which is negative 2, times negative 2.19 plus a of y, we got negative 3 times by, which is 6.01. All right, and then that's going to give us our answer. So if we solve those parts, 4 times negative 2.19, that's going to give us negative 8.76. So a times b equals negative 8.76 plus, and then negative 3 times 6.01. That's going to give us negative 18.03. Negative 18.03. And then if we just solve that, negative 8.76 plus negative 18, or just minus 18.03. We're going to get negative 26.79. 26.79. can be rounded to, so A times B equals, and that can be rounded to negative 26.8. And that's the answer for part C. That's all there really is to it. All right, so now we will move over to part D. I'm going to make a piece of paper. Just flip this one. Because now we're basically on completely new questions. So we shouldn't need anything on that page for the rest of it. So now for part D. Part D says vector C has a magnitude of 6.50 and is at an angle of 55 degrees measured counterclockwise from the positive x-axis towards the positive y-axis. So that means that it's a true angle. It's not doing any of the north, south, east, west, or anything like that. It's just from the positive x towards the positive y, so it's going to be moving in that direction around the graph. So vector C has a magnitude of 6.50 and an angle of 55. So it's going to be about like there, I think. That's kind of the guesstimation. That's going to be vector C, magnitude 6.50, and the angle is 55 degrees. Okay, and then it says vector D has components dx equals positive 4.80 and dy equals negative 8.40. Calculate the scalar product. So it's going to be doing the same steps as the last step, but it's given us some information already. So we have vector C, its magnitude and its angle. Vector D we do not have, but we do know that we do know its components. So d of x equals 4.80 and d of y equals negative 8.40. And that honestly, it makes it easier because now we don't have to find those components. We only have to find vector C's components. So the first step would be to find vector C's components. So for vector C, we're going to use v of x equals v cosine theta, and v of y equals v sine theta. And then we're going to plug it in for C. So C of x equals 6.50 cosine of 55, and C of y equals 6.50 sine of 55. And then we're going to figure out C of x, C of y equals, I guess that should really be like an arrow. There we go. All right, so, and if we just plug that in, 6.50 cosine of 55 equals 3.72. 3.728, so 73, 3.73. And then for CY, we got 6.50 sine of 55 degrees. That is 5.32. 5.32. So that's our our x component and our y component. And so now that we have both of these, we can just plug them into the same equation from this page, which was the scalar dot product program formula. So it's the it's the vector A times vector B equals A of x times B of x, but instead it's going to be D of x and C of x. So we're trying to find C times D. So C times D equals C of x times D of x plus C of y times D of y, and I have no z, so that's going to be the whole thing. So C times D equals, and then we just plug it in. So C of x is 3.73, 3 point, right? So 3.73, yeah, 3.73 times D of x times D of x, which is 4.80, 0.80 plus C of y, which is going to be 5.32, 5.32 times D of y, negative 8.40. And then we're just going to solve. 3.73 times 4.80. It's going to give us 17.904. Plus 5.32 times negative 8.40. It's going to be negative 44. Negative 44.69. And then we're just going to add those together. So it would be 17.904, really just minus 44.69, and that gives us negative 26. So C times D equals negative 26.78. What did we round the other one? 26.78. So 26.8. Around 26.8. So it's the same answer, actually. Yep. Yeah, it's the same answer. So yeah, that's how you do that one. Okay, now we will move on to part E. And part E says, find the angle between vectors C and vectors D. All right. So, in order to do that, we have to, we'll do the first step to do that. We have to find the magnitude of vector D, actually, because we only have the component forms. The reason why we have to find the magnitude is because of the formula for finding the angles between vectors C and D. So the formula that we are going to use is going to be, it's from the geometry formula for component form of a vector. So you have, scalar dot product. Scalar dot product. So you have this formula for scalar dot product, and then there's another formula to also find the scalar dot product, and that one is which one was that? I'm just trying to remember now. Oh yeah. So it's A times B, right? Because that's what you're trying to solve with that formula, equals the magnitude of A times the magnitude of B cosine theta. So you can also find it using this, but we can also use this to find cosine of theta, because to find the angle between the two equations, you actually need arc cosine of theta, and the theta in this is actually cosine of the angle. The cosine of the angle, but you don't actually know the angle. That's what you're solving for, is cosine of angle, and then whatever this equals, you plug it into this. So with a little just algebra, you divide this by that, and then you divide it by over here too. And then that ends up equaling cosine theta equals A times B over magnitude A times B. Those are the vectors, and then that's how you find that. And then once we find cosine of theta, we'll plug that number into arc cosine theta, and that equals the angle, which the symbol, find the angle, the symbol they use, no, I think it actually looks like theta. I think that's the symbol that they use. So yeah, so that's what we got to do. So we just have to figure out everything to plug into, but we're doing everything in terms of C and D, of course, vector C and vector D. So we just solved for the product of vector C times vector D, and that's negative 26.8. So that's the top part of our formula right there. Here, I'll write it out. I'll write it out in terms of C and D. So cosine theta equals C times D, so vector C times vector D, over magnitude of C times magnitude of D. And so we have everything for this whole formula except magnitude of D, because it gave it to us in vector form, in component form. So we just have to find magnitude of D. So that's another formula. And so the formula to find the magnitude of something, magnitude of a vector equals the square root of component of vector x squared plus component of vector y squared. And so that's how you find that. So in order to find the magnitude of D equals the square root of D of x squared plus D of y squared. And then we're just going to plug that in because we got all the values up here. So we got magnitude of D equals square root, and then D of x 4.80 squared plus D of y negative 8.40 squared. And then we just plug that into our calculator. And it should give us the answer. So we got square root 4.80 squared plus negative 8.40 squared. And we solve for that. And we should get, let's see, we got 9.674. And so that would round to 9.67. And so that is going to be our magnitude of D. So then we have the magnitude of D. We have the magnitude of C, which is the one that they gave us up there. They gave us that one in part D. And then we have the product of C times D, which is negative 26.8. And we're just going to plug all of that into that equation right there. So yeah, let's do that. cosine theta equals, and then it will be negative 26.8 divided by magnitude of C 6.50 times magnitude of D 9.67. And then we just solve that. So that's going to be negative, actually we'll solve the bottom part. So 6.50 times 9.67, that equals 62.85.5. So we'll write that out too. Cosine theta equals negative 26.8 divided by 62.855. And then you do that, negative 26.8 divided by 62.855. That's going to give us negative 0. So cosine theta equals negative 0.426. We'll do it to 3 decimals. And then we found cosine of theta equals negative 0.426, but we're not done. That's not the angle, that's the cosine of the angle. So we have to find the arc cosine of the value that we just got. So if we plug that in, arc cosine theta equals, arc cosine, sorry, I have the equation written backwards. It's technically angle equals arc cosine of the value we just got, negative 0.426, and then if we plug that in, arc sine is also inverse sine, so cosine inverse of negative 0.426, and that's going to give us the angle of 115.21, but we can round that to the angle equals 115 degrees. And so that's the angle between vectors C and D. So let me rewrite that. So it's going to be the angle between C and D. It's going to be 115 degrees. And that's that. All right. Now, okay, so that was part E. So now we're on to part F, and it's given us a whole new problem for part F as well. So part F says vector A has components AX equals negative 5, and AY equals 3, and AZ equals 0. So we got a Z now. Vector B has components BX equals 2.50, BY equals 4, and BZ equals negative 1.50. Find the angle between the two vectors. So we're going to do the exact same thing, basically, that we did over here. With the, can you see both of those sheets? There we go. Okay, I got tape here, just make sure. Okay, cool. So we're going to be using arc cosine. So to find the angle, so okay, let's write them all out. So vector A, we have A of X equals negative 5, A of y equals 3, and A of z equals 0. And then vector b, vector b, we got bx equals 2.50, we got by equals 4, and bz equals negative 1.50. And we got to find the angle between the vectors. So to find the angle equals the arc cosine theta, and to find the theta for the arc cosine, we're going to be taking cosine equals the two vectors, so the vector A times vector B, so the dot product over the magnitude of A times magnitude of B. And remember, that's all from the dot product formula over here. That was that A times B, the A vector times vector B equals the magnitude of A times B times cosine. That's how we get that. And so we have to just figure out all the variables for that. So our first step, well, we have all the components, so I say we find A times B. So remember, A times B, the product of vector A times times vector B equals A of x times B of x plus A of y times B of y plus, and now we do have A of z times B of z. And then we're just going to plug that in, and we'll get the top part of our formula. So, B equals our A of x, negative 5 times 2.50 plus 3 times 4 plus 0 times negative 1.50. All right, and that's that. So let's solve for those. We got negative 5 times 2.50. That's going to be negative 12.5 plus 3 times 4 plus 0 times negative 1.50, 0. And so that will equal negative 0.50. Because 12 cancel out. We're left with 0, that cancels out. So I actually didn't even need that, but still. Yeah, negative 0.50 is what vector A times vector B. So that's going to be the top part of this equation right there. Right, you can see that? Yeah, okay. So, yeah, there we go. The next thing would be to find the magnitudes. So now we just need the magnitude of A and the magnitude of B. Remember, so the equation, right, because part F, yeah, we're just looking, okay, yeah. So the equation for magnitude, is magnitude of a vector equals the square root of the components of Vx squared plus Vy squared plus now Vz squared. And then we'll plug that in for A and B. So we got A, magnitude of A equals square root ax squared plus ay squared plus az squared. And B, magnitude of B, bx squared plus by squared plus bz squared. And now we're just going to plug them in. -5 plus 3 squared plus 0. And I mean, I won't even add x. It's just 0. And then for B it'll be something. B, we got 2.5 squared plus 4 squared plus -1.50 squared. Okay? And then we'll just plug these into the calculator. So we get for A 5.83, round that to 1, 5.81, and vector B, wrong button. There we go. We get 4.949. And that could really be around that 4.950. Okay, so we got the magnitude of A, magnitude of B. We've got the A times B. Now we just plug it in the formula. Cosine theta equals A times B over magnitude of A times magnitude of B. Now we plug that in. -0.50 divided by 5.831 times 4.950. So go back over here. Cosine theta equals, just plug that in. So we'll get -0.50, or actually let's do the bottom. So 5.831 times 4.950. That gives us 28. We'll do that. -0.50 divided by 28.863. All right, now we do that. Negative 0.15. Oh, no. Negative 0.50 divided by 28.86. And the angle that we get is, well, that's not the angle. Remember. The number that we get is negative 0.0173. All right, and then we plug that into angle equals arc sine, or arc cosine of theta, and the theta is the number we just got. So angle equals arc cosine theta. So angle equals arc cosine of negative 0.0173. Let me plug that in. Angle equals, and I'll plug it in, negative 0.0173. And we get 90.99, which would be rounded to 91 degrees. And that's the angle between the vectors A and B. And that's that. All right. Let's move on to get I'll get two just in case. All right. So okay, you still see both of those? Yes. Okay, cool. Now we're on part G and H, last two parts. So, these are completely, well, these are completely new questions. We don't actually need the paper because it didn't have anything to do with the previous question. Okay, so, because they're really like all different questions. Part G. All right, this is a long one. If a force, or vector F, acts on an object as that object moves through a displacement, or vector S, and that's a common notation, is using, so using F vector to represent force and S vector to represent displacement. That's like a really common thing. Okay, so if a force acts on an object that moves through a displacement, which is vector F, the work done by that force equals the scalar product of F and S. So it gives us an equation that says work, or W, equals the scalar product of F times S. So vector F times S, or force times displacement, which when you're dealing with vectors, they're basically just two vectors. But in physics, one is force and one is displacement. Well, in this problem, they are at least. A certain object moves through displacement, vector S equals, okay, so then it gives us vector S. It gives us vector S in component form, but in a different way. So it says vector S equals 4 meters. and then it writes it as I plus 5 meters, and then it writes it as J. As it moves, it is acted on by force. So vector F. It's acted on by vector F, which has X component. So then it gives us F of X equals negative 12.0 newtons. And that newtons is the unit for force, is newtons. And then it says, okay, so we have F of X, and then it says the work done by this force. Wait, what? Oh, okay. And then it says the work done by this force is 26.0 Newton meters, or 26.0 joules. And then it says joules, 1 joule equals 1 Newton meter. And then it says find the y component of F. So F of y is what we're trying to find, and we're given this. And we're also given, so it says the work done equals 26 newtons. So it gave us W, and it gave us actually everything we need to find vector S, and then it gave us the X component of vector F. So for the sake of this problem, it's a lot easier to think of just all of these as vectors, and we're just trying to find W. So this that it gave us is really just the X and Y components of vector S for the sake of this problem. So S of X equals 4 meters, if you want to put that, and then S of Y equals 5 meters. So those are the X and Y components of vector S, and then we have the X component of vector F, and we have to find vector Y. So hold on, I'm gonna drink some water. So to find this, we can actually use the scalar dot product formula. So the scalar dot product formula is, if we remember, vector A, right, vector A times vector B equals, and then you divide it into the things. So A of X times B of X plus A of Y times B of Y. So right, so this is our scalar formula. Now, in this equation, work, they told us work equals F times S. So W equals this. So for the sake of this, it's actually, the formula will be W equals, and then we sub for the variables that they gave us. So W equals F of X times S of X plus F of Y, which we don't know, times S of Y, which we do know. So the only variable that we don't know in this whole formula is that one. So we can just plug everything in and then solve for that using a little bit of algebra. So let's do that. So W is 26. So it's 26 newtons equals negative 12 for F of X. For F of X. Times S of X, which is 4, plus F of y times s of y, 5. All right. And so we just have to solve for f of y. So we can do that by first solving. So negative 12, right? Yeah, negative 12 times 4. That's going to be negative 48. So we're going to have 26 equals negative 48 plus, and we can really just write this as 5 fy. And just, I mean, we're just treating it like an x. So then we can do plus 48, plus 48. So that's going to be, I don't feel like doing that math. 26 plus 48, 74. Okay, so that'll give us 74 equals 5 fy. And then we just divide by 5. Divide by 5. So then we will have fy equals 74 divided by 5, 14.8. 14.8. And the f variables are in newtons, so that would actually be 14.8 newtons. And that's how you find f of y. So yeah, we'll always show newtons if we know it's newtons. And then if we were solving for s of y, it would be in meters because that's what the problem gave us. So now, yeah, that's it. So now the last part is we're going to do part H. So part H says find the angle between vector f and vector s. So it's the exact same thing that we have done 3 times now. So maybe more. So to find the angle, we need arc cosine of theta equals angle, and to find the theta equals cosine of theta, and to find cosine of theta, it equals a times b all over magnitude of a times magnitude of b. And now we just have to do all that. So, just want to make sure. Okay, yeah, you can still see it. So, but we're dealing in terms of f and s. So we're going to sub this out as cosine theta equals vector f times vector times vector s over magnitude of f times magnitude of s. All right, now let's see. Do we have anything? Yes, we have f times s because we know work equals f times s, and work equals 26. So we already have that. So plug that in. Cosine of theta equals 26, and it's newtons. And then, yeah, we just have to find, because we don't have the magnitude yet. No, we do not have the mag, right? They haven't given, they haven't given this magnitude. So we just find the magnitude, and to find the magnitude, that's the magnitude of v equals square root b of x squared plus b of y squared plus c of y, but we don't need that. So, and then we just yeah, so we're going to plug that in for f and s. So magnitude of f, because we just found f of y, yeah, all related. So magnitude of f equals square root f of x, which is going to be negative 12 squared, plus f of y, which we just found, 14.8 squared. So magnitude of f equals, we're just going to plug that in. So negative 12 squared plus 14.8 squared. That is going to give us 19.05. And I believe that would be in newtons, because both of those are newtons. So 19.05 is the magnitude. For that. I think it's in newtons. And then we just have to find the magnitude of s. So we'll do the same thing. Magnitude of s, I'd like to stay on this page if I can, equals square root of, well, I guess I'll write out the formula. S of x squared plus s of y squared. So magnitude of s equals, and then we plug it in. So s of x square root 4 squared plus 5 squared. So we got 4 squared plus 5 squared, 6.40. So magnitude s, can you see that? Yeah, magnitude of s equals 6.40. So now that we have magnitude of f and magnitude of s, we can plug it all into the formula over here. So it would be 19.05 times 6.40, and then we'll do that. So we got 19.05 times 4. Times 6.40. That's a big number. 19.05. Should be right. 120. I'm gonna do something. 19.6.4. Now let's see. 26 divided by 0. Oh, that's correct. That looks like that'll be right. Okay. All right. Second guess myself. Okay. Cosine of theta. Cosine of theta equals 0.213. 3. Now we'll round it to that. Okay, so that's the cosine of 0, but that's not the angle. We still gotta find the angle. We find the angle by doing the arc cosine of that number. So arc cosine of 0.2133 equals the angle. So angle equals, you plug that in, 0.2133. Bam, 77.68. We'll round that to 77.7 degrees. that's part H. And that's the whole thing. That's the whole thing. So that. Hope you enjoyed the video. And yeah, thank you very much. Hour and 5 minutes.